Okay. I want to welcome everyone this evening to our first President Lecture Series of the academic year 2017-2018, or 2018-2019, I should say. And we're excited for all of you to be here and to enjoy this evening. One of the things I'll start by saying is you might wonder why there are only three of us sitting on the stage, and that's because there's been some change in our speakers this evening, and we're sorry about that, but one of our speakers, Dr. Michael Drews, he had a medical emergency on a personal basis, so he's not able to join us tonight. And another individual, Dr. Shannon Manzi, she could not be here this evening as well because she was deployed last week as part of an emergency team to Florida due to Hurricane Michael. So tonight we're going to have a smaller group speak to you, but it just means that there'll be a lot more time for questions, and hopefully you can get more information that you ordinarily would have gotten. So again, welcome, and before I introduce the speakers, there's a few housekeeping things that I'd like to tell you about. And one is that many of you are here to receive continuing education units as part of nursing, and it was approved for 1.83 contact hours by the American Nurses Association of Massachusetts, and they are the accredited approver by the American Nurses Credentialing Center Commission on Accreditation, just so that you know that. And in order to receive your CEUs, you must stay until the very end, and that includes the question and answer period. Additionally, in order to get your CEUs, you must hand in an evaluation, and you will sort of exchange that for your CEUs when you're leaving. But if you're not requesting CEUs, we do hope that you'll fill out the evaluation form as well, because we really value your input. It's very helpful to us. I actually sit on the President Lecture Series committee, and when we try to decide what topics we're going to have for future panels, we always look back to see what the evaluations have said and what the recommendations are, or things that are interesting to you as the audience members. So don't hesitate to write down what you'd like to see in the future. We really welcome that. And for those of you who were not able to print the PowerPoint slides, they are posted on the website where you registered, and you can download them after you leave if you haven't had a chance to do that prior to coming this evening. And the slides will be available until November 1st, so you're not going to miss out by not having them tonight. And another note that I want to make sure that everyone is aware of, that Regis College expressly prohibits attendees from recording and or rebroadcasting the lecture by any audio or video means, and we really thank you for your cooperation with this. So, my name is Joni Bashansky, and I realized I didn't say that at the very beginning. I am an associate professor of medicine here at Regis College, and I'm also the director of a graduate program in regulatory affairs and clinical research management. I have a background as a clinical research scientist, and I look back on my career, and over 25 years ago, I was doing decision analysis consults on individual patients, trying to determine what was the best treatment for a patient. Should someone get an aortic valve replacement, or should they just have medical treatment? And we would go through a decision tree and try to determine what we should do for that particular patient. You can only imagine that took a lot of effort and time. It was computer generated, but it really was a tedious process. We also worked at developing algorithms, and we incorporated equations into electrocardiographs so that when someone did an electrocardiogram in an emergency department, it would print out the likelihood that this person was actually having a heart attack, or that this person's mortality was 30% based on that individual's information incorporated right into the algorithm. But that was relying on age, on gender, what someone's family history might have been, and whether or not that patient was actually presenting with chest pain as a chief complaint, a secondary complaint, or maybe they didn't have chest pain. And it took into consideration changes on the electrocardiogram. But that was well before we actually mapped the genome, and that we found out all about genes and genetics. And now it's taken us to a whole other level. And it's taken us to where we are even tonight about personalized medicine and what our new reality is, because it's very different than it was 25 years ago. It's even very different than it was 10 years ago from now. So let me tell you about the speakers that you're going to hear from as we go forward tonight. Our first speaker will be Kristen Shannon, and she is the director of the Cancer Center Genetics Program at Massachusetts General Hospital and professor of genetic counseling in the School of Health and Rehabilitation Sciences at the MGH Institute of Health Professions. She is a certified genetic counselor, a member of the National Society of Genetic Counselors, and the American Society of Clinical Oncology. Ms. Shannon brings years of experience in genetic counseling to the presentation this evening, and she began her career at Dana-Farber and then moved to Mass General, where over a period of 20 years, she went from being a genetic counselor in the Cancer Center Genetics Program to her current position as director. Prior to becoming the director, she spent most of her time providing cancer risk assessments for members of high-risk breast, ovarian, colon, and endocrine cancer families. Also by providing predisposition testing counseling for cancer susceptibility genes, as well as developing research and clinical trial protocols and instruments to determine predisposition testing for cancer susceptibility genes. She's an author of over 47 peer-reviewed journal articles and 7 book chapters. She's going to speak on personalized medicine in oncology. Our second speaker will be Laura Hausman, and Laura is the founder and CEO of Access Solutions Consulting, a company that provides global healthcare commercialization services offerings in support of patients, providers, payers, and pharmaceutical organizations. Laura has over 25 years of hands-on experience in healthcare strategic development, program management, personalized medicine, sales and business development, market access, regulatory and health policy, payer managed care organizations, and drug development that also includes negotiation, pricing, and reimbursement. She has successfully launched over 30 products and services across diagnostics, software, and drug development. She is also an adjunct faculty member at the Massachusetts College of Pharmacy and Health Sciences and an executive in residence in the Boston University School of Public Health's Executive in Residence program. That program provides a platform for the executive, such as Laura, to lend their expertise to both faculty and students through lectures, workshops, and mentorship. Additionally, she serves as a chair for the Board of Health in the town of Framingham, pretty close by here, and is often an invited lecturer at national and international conferences in her area of expertise. She'll be speaking on personalized medicine kind of in the future, 2028, and the issues and barriers to implementation in practice. To date, none of our lecturers have any conflicts, and if they do, they will let us know about that. But we'll start with Kristen.
Hi, so thank you so much for that introduction, and thank you for inviting me to come. I was just telling my 2 speaker colleagues here that when I was initially invited to come, I'm a genetic counselor, I've been doing this for many, many years, and the topic of personalized medicine, I said, I don't do personalized medicine. And it was my supervisor that said, yes, you do. This is what you do every day. So I think we all have our own views of what personalized medicine is and where it's going. What I wanted to do today is to tell you what my view, where I sit in the oncology clinic, and what personalized medicine is for us and the patients that we treat. So I have, in the interest of being completely transparent, our group did receive a gift from AstraZeneca. It has nothing to do with this talk at all. It was to develop a patient-related educational video, but I just want to make sure that I'm completely transparent. So just a minute about genetic counselors. So genetic counselors are master's degree trained healthcare professionals. We go through a 2-year program after bachelor's. We're certified and licensed in the state of Massachusetts, and we really have expertise in translating complex genetics information and help patients decide about genetic testing and whether or not they want it. So typically when we see an individual for genetic counseling, we start off and take a detailed medical and family history. We review their siblings, aunts, uncles, cousins, grandparents, cousins, all that health history, and provide them with a risk assessment. You know, how likely is it that the disease in question in your family is due to a gene versus an environmental factor? We talk to them, educate them about genetics, describe genetic testing, what it can and can't do for them, and then help them make a decision about whether or not they want to proceed with genetic testing. So this is my Cancer Genetics 101 lesson in 2 minutes, and this is not to insult anyone's intelligence, please forgive me. It's just to make sure that we're all on the same playing field. So we all know that our bodies are made up of millions and millions of cells that is represented by these green circles. So in every cell of our body, we always have 2 copies of every single gene. You get one from your mother and one from your father. Now, the genes that I'm going to be talking about specifically are cancer genes, and so all of these genes, for the most part, when they're working correctly, they're keeping your cells healthy. So you always want all these genes to function normally. What causes a gene to not work is called a mutation. So if someone has a mutation in one copy of a gene, say in this cell, this copy, this purple bar, represents a mutation. So this copy of the gene does not work. This copy does work. This cell is still perfectly fine and healthy. If in that same cell, the other copy of that gene becomes mutated, then this cell all of a sudden is not healthy any longer, and it will grow out of control into a tumor. Okay? So this is basically, it's a very simplistic view of how cancer happens. In effect, it's multiple genes all mutated together to get full progression, but this is a very simplistic view of the progression from a healthy cell to a cancer tumor. In my world, we work and what we're trying to do for the most part is identify people who are born with one copy in each one of their cells that's already carrying a mutation. So you can see in this lower panel that people that have mutations, they only need this second hit for them to develop a tumor, okay? Most cancers fall into the top panel that I just showed you. So the vast majority, 90 to 95% of the time, cancer is not inherited. It's what we call sporadic. So it's multiple hits over the course of a person's lifetime. If, however, a person does have a hereditary predisposition, or if they carry a gene mutation, then there's a 50-50 chance that it's passed on to each generation. So they could either pass on the gene mutation or they could pass on the other copy of the gene to their children. So when you think of individuals that do have these gene mutations, you typically, when I take their family histories, you see a lot of people in the family that have been diagnosed with cancer. You see multiple people in multiple generations of the family, because these gene mutations are passed on from generation to generation, so there's many generations that are affected. We typically see early age of diagnosis as well. Remembering back to my original slide, over the top panel is multiple hits over the course of the lifetime. The bottom panel just represented it only takes one other hit for a person to develop cancer. The other thing that we see is individuals getting multiple primary cancers because this mutation is in every single cell of their body, so they can get a breast cancer in the left breast, for example, and then be treated and be fine, but then many years later get maybe another breast cancer in the other breast. So that's my Cancer Genetics Lesson 101. The other thing that I do want to mention just about the cancer genes that we most often talk about in the clinic, these genes are only important in specific tissues of your body, right? So my for example is eye color. Your genes that code for your eye color, they're important in your eye, but they don't do anything in your pancreas or your liver. So if there's a mutation in a gene that codes for your eye color, you might have a funky looking eye, but it's not going to affect any other tissue of your body. So these genes that I'm going to talk to you about, if someone carries a mutation in one of these genes, they are at risk for specific types of cancer. So I think most of us have heard about the BRCA1 and BRCA2 genes, the BRCA genes. If someone carries a mutation in those genes, they are specifically at risk for breast cancer, ovary cancer, prostate cancer, and pancreas cancer. They're not more likely to get a lung cancer or a brain tumor. It's very specific to the tissue of the body. Okay, so that was my level playing field. So now the only other thing that I want to talk about before I get into my the cases that I want to talk about in terms of personalized medicine is this other idea of genetic testing. So where I sit in the clinic most of the time, I'm talking to people who are interested in finding out whether or not they carry an inherited predisposition to cancer. So those are those people that have their blood drawn. and we're testing their overall genetic makeup. What genes are present in every single cell of their body? Medical oncologists, who I work very closely with, they're actually doing testing, genetic testing on the tumor itself. So a lot of times people will come in and say, I already had that genetic testing done. And the genetic test indeed was run, but it was looking at the genes in the tumor and not what's in the germline, okay? So if you have a mutation that's identified in the tumor, we know it's here, but we don't know where the person started. Did they start and have to have 2 hits to get there, or was it only 1 hit? So tumor testing does not translate into germline testing. So why do you need genetic testing on tumors? So we're looking at the genetic profile, and this is when it comes into being personalized medicine. So there's always a genetic signature on every single cancer cell. And what the goal of personalized medicine and personalized treatment is in the oncology setting is to develop drugs to target that specific gene signature and stop that cancer from replicating and dividing. So it's to develop chemotherapeutic agents that are very, very effective based on what the cancer and the tumor's genetic profile looks like. Other people would, and that is in contrast to why people are interested in germline genetic testing. So germline genetic testing, again, that is an overall look at what is present in every single cell of the body. Individuals, however, do want this information to make personalized medical decisions in a couple of different areas. So first of all, it can help them with their treatment decisions. So there are certain chemotherapeutic drugs that we know actually work better when the overall person has a mutation in a specific gene, and I'm going to get to that in a minute. It also can help with surgical management. So for example, would be a woman who is diagnosed with breast cancer and we know has a significantly elevated chance of getting a second breast cancer in her lifetime. Some women would want to know at the time of diagnosis whether or not they have such a high risk of getting a second cancer, so that they, instead of having breast conservation therapy, which is a lumpectomy and treatment, they might consider having both of their breasts removed. So one breast removed to treat the cancer, and then because they have such an elevated risk of getting a second cancer in the future, they might have the other breast removed prophylactically. So that's an idea of someone with it that's undergoing genetic testing to help with their treatment decisions. The other thing about these cancer risk predisposition genes is that, as I said before, they put you at risk for developing other types of cancer. So if a woman has a BRCA mutation, she, in addition to choosing whether or not she might have her breasts removed, she's also at risk for ovarian cancer, and that could change her future management for ovarian cancer. And then other people also do genetic testing purely for the sake of the family. So when something is inherited, remember, it's a 50-50 chance that you pass it on. That means that your siblings are at 50-50 risk. You most likely inherited it from one of your family, so that means your cousins are at risk. And that's another really big benefit for doing this in an individual and for the individual's family. Okay, so I now want to just move into 3 kind of case stories that I'm going to toss out there that give you a little bit of insight as to how we use this actually in the clinic. So my first case is Rob. So he's 63 years old and came in with a persistent cough. He reported that when he was in college he smoked casually, but he was not a heavy smoker. They did a chest x-ray, found a lung mass, which was biopsied, and he was diagnosed with non-small cell lung cancer. During his workup and CAT scans and blood work, they found out that he had stage 4 disease, which is widely metastatic, and his physicians started talking to him about chemotherapy and treating at that point. From the social and familial perspective, he's married and he has 2 sons and 1 daughter. And he reported that his maternal grandmother, so his mother's mother, had lung cancer and died at age 87. She was a heavy smoker, and there was no other cancers in the family. So Rob came in, and his physician started talking to him about chemotherapy, but they also started talking to him about testing his tumor. So why was that? So they tested his tumor and they found out that he had something called EGFR positive non-small cell lung cancer. So EGFR is epidermal growth factor receptor, and that this is a protein that's normally found on all cells of our body. And what it does is it helps with cells growing and dividing and just kind of keeping them healthy and dividing. What we have found is that if there is too much EGFR in a cell, it makes that cell grow out of control so fast. And that's why these cancers grow really, really fast. There have been newly developed, not so new anymore, Laura can probably talk about this, but there are chemotherapies that act specifically at the EGFR gene to stop that cell from growing. So these drugs for Rob, who has this EGFR positive cancer, he can get these drugs and he will respond incredibly well. So my understanding is that about maybe a quarter to a third of all individuals with non-small cell lung cancer will have an EGFR positive lung cancer. And it has been shown that with treatment with one of these EGFR inhibitor drugs, their statistically significant life expectancy is outrageously, unbelievably crazy. So for this, Rob found out that he had actually a much better prognosis than he originally found because he had this new treatment option. I just want to mention a second about what it meant in terms of his other cancer risks. So remember, we only looked at the tumor itself. We don't know if he was born with this EGFR mutation and then it progressed to developing a lung cancer or not. I can tell you from statistics, there's only been maybe 2 or 3 families in the entire world that have been diagnosed with inherited EGFR mutations. So most of the time these are somatic events and they just happen randomly. But it doesn't tell us anything about what his future risk of developing another cancer might be. And it also doesn't tell us anything about his family, how likely his family is to get lung cancer. My second patient is Florence. So she's 55, and she was recently diagnosed with pancreatic cancer. She had a Whipple procedure to have her pancreas removed and was undergoing chemotherapy and is responding incredibly well to therapy. So she's doing great. She reported that her paternal aunt was diagnosed with breast cancer, and she passed away at age 60, and none of her maternal relatives had cancer. And Florence has 1 son and 2 daughters. So for Florence, her doctor and her genetic counselor really wanted to do the tumor testing and the germline genetic testing at the same time. So why was that? Again, we wanted to start with the tumor testing. And so we looked at the tumor, and this was to help direct her chemotherapy treatment. And we found that she had a mutation in a gene, and we needed to track it back. Did she have it in her germline or not? So she was found to actually have a Brca2 mutation. And these are the statistics associated with Brca2 mutations. The Brca2 mutation was initially found in the tumor itself. We couldn't tell if it was actually present in her germline or in every single cell of her body. So we had to draw a tube of blood, send it off for her testing, and she did actually carry a germline Brca2 mutation. So this is what we know about her risk of developing cancer. So she's already had pancreatic cancer, which is increased. But she now knows that she has a significant risk of developing breast cancer, ovary cancer, and her brothers and sisters and son might be at risk for prostate cancer as well. So these numbers are really high. Women with Brca2 mutations can have up to a 85% lifetime risk of developing breast cancer. They can also have as high as a 30% lifetime risk of developing ovarian cancer. These are really powerful, powerful genes. So for Florence, we know that her tumor actually had a Brca2 mutation, and for her, we were actually able to put her on a PARP inhibitor. So PARP inhibitors are fairly new in the realm of genetic testing and in the realm of cancer treatment. PARP inhibitors have been FDA approved in treatment for ovarian cancer and in treatment for breast cancer. They are not currently approved for pancreatic cancer. However, having this information gives her the ability to enroll in a clinical trial to look at how effective PARP inhibitor would work. And we have seen dramatic effects with the use of PARP inhibitors that target the actual DNA damage that the underlying cause of the BRCA of the cells. The other thing that Florence learned with all this test and how her personal management plan changed was because of the risks for breast and ovarian cancer, we knew that we needed to keep a much higher, closer look on her. So in addition to having mammograms every year, we want her to have breast MRIs every year. We also want her to see a surgeon that's well-trained in breast cancer and do a clinical breast exam at least twice a year. The other thing we talked to her about was ovarian cancer. So as many of you know, ovarian cancer is very difficult to diagnose at an early stage. And the goal of all of this is to try and find a cancer when it's early stage. And unfortunately, ovarian cancer does not lend itself to that. So the option that we have right now for women with Brca mutations is to have their ovaries and fallopian tubes prophylactically removed. So for Florence, she had already experienced this pancreatic cancer. She was doing really well, and she just wanted to make sure that she didn't have to go through another cancer diagnosis at some point in her future. So she had her ovaries removed, and she's being screened for breast cancer currently. Looking to the family information, and again, this is a very personalized risk for Florence and her family. Her daughter at 30 was tested, and she tested positive. So she is 30, so we need to watch her again with MRIs and mammograms every year. We talked to her about ovarian cancer, and the current recommendation is that once women have completed their families, as they get to be about 35 or 40, we actually talk to them about having their ovaries removed. So her daughter is feeling a little bit of pressure to have the babies quickly before she has the surgery. Her 25-year-old son also tested positive. And for him, the cancer risks and the cancer management for him doesn't change until he's a little bit older. Men with Brca2 mutations can get breast cancer. The screening for men is much less structured. It just consists of a clinical breast exam every year. Most men don't have enough tissue to get a mammogram or a breast MRI. And then we want to start him with prostate cancer screening at a much earlier age. We would start him at age 40 for screening for prostate cancer. Florence's 22-year-old daughter did not get tested. Most of the clinical screening guidelines tell us that we start enhanced screening at age 25. She just didn't want to know yet. And I think that's a fascinating dynamic that we have in these families. People make decisions totally differently, and it really can upset the family relationships, but this is one. She didn't need the information. Her clinical management was not going to change in the short term, so she just said, I'm going to wait until I'm 25, and then I'll cross that bridge if I have to. Then they also told their family, their paternal family, because Florence did have a paternal aunt that had breast cancer, so we presumed that it was being inherited from her father. So we told all the paternal relatives that they could benefit from this genetic testing as well and help them create a personalized medical management plan based on their germline genetics. My last case is Suzanne. So Suzanne is a healthy 43-year-old woman. She's really interested just in learning about health risks and genetics and ancestry. So she went and bought a direct-to-consumer genetic testing kit, which I think we've all heard of. And Laura's probably going to talk a lot more about. So she spit into her tube, packaged it up, and mailed it off. In terms of her family history, so her mother, her grandmother, maternal aunt, all three women were diagnosed with breast cancer at very early ages in their 40s. Her paternal grandfather was also diagnosed with lung cancer in his 80s, and Suzanne had one daughter and one son. So she actually didn't come in to see a healthcare provider. She just did this direct-to-consumer test on her own, and just because she was just interested. So she found out a lot of things on this test report. mostly about her ancestry and that she was Irish and German and Scottish. There was no variants that were associated with Alzheimer's or Parkinson's disease or breast cancer or anything. So she was thrilled with this test result. She thought she was just an average risk woman in the population. She still needed to get her mammograms, but she wasn't at all concerned about it. So for Suzanne, how did this impact her? I think, first of all, she didn't have an existing cancer, so it didn't have any impact on any treatments. But it's important to note that direct-to-consumer testing for Suzanne in her case, her test was not complete. And it was not complete for a couple of reasons. So my message for about direct-to-consumer testing is just buyer beware. Just know what you're getting yourself into. So most of the genetic testing companies that offer genetic testings for breast cancer risk, some of them do actually test for BRCA1 and BRCA2, but they only test for 3 mutations that are more common in the Jewish population. So Suzanne being German and Irish, that test was completely meaningless to her. And what we suggest to Suzanne is that she undergo clinical genetic testing for BRCA1 and 2 because a mutation could have been missed. Given her family history, she had a mother, an aunt, and a grandmother with breast cancer at an early age. That smells a little funny in terms of an inherited predisposition. And so the over-the-counter test did not give her enough information to help her make best medical management decisions. And the other thing is that it didn't give her any information about her family and whether or not other people should be tested. So in Suzanne's family, we as genetic counselors would have said, have your mom come in. We'd like her to get tested for BRCA1 and 2. And actually, there's 10 or 12 other breast cancer related genes that we want to test her for. And if her mom came in and tested positive for one of those genes, then we would really be able to clarify Suzanne's risk. But just by doing this test, I think it's very interesting. I think it gave Suzanne a lot to think about, a lot to understand, but we wouldn't want Suzanne to make any kind of medical management decisions based on this test because the test itself just wasn't complete. That's it for me. And I think Laura's going to give a lot more talking about it.
That's great. Thank you, Kristen. We'll wait until the end till we take questions, and now I'll have Laura Hausman.
Thank you and good evening. Can you hear me? Yeah, okay, super. So wonderful to be here this evening. Thank you to Joni, to Kristen, to Penny, and to Regis. And thank you to each of you. I know from personal experience it could be a long day of studies and work and family. I appreciate your taking the time with us this evening. This is an area that is evergreen, always changing. Every day it's like ripped from the headlines. There's something new related to personalized medicine and genetic testing. Kristen's done such a great job of teeing up some very important and interesting case studies that are very relevant for the decisions that each person is making. And I will tie in a little bit from the broader market access perspective to give some context. Like, for example, Kristen's case of Rob, his 63-year-old, yes, who had the somatic cancer of non-small cell lung cancer and was recommended to have a pan-cancer genetic panel test. Up until a few months ago, that the market-leading test that would have likely been ordered was not regularly covered by insurance and was not covered regularly or at all by Medicare. So that out-of-pocket cost to Rob would have been about $3,500 to $7,000. If in fact the test manufacturer sought full reimbursement out of pocket from Rob. because that's not in the best interest of the test manufacturer, who wants to establish more usage and have more data to be captured as part of their testing, there was likely some patient assistance program where maybe a fraction of that amount was paid for. But it is putting into context the innovative aspects of genetic testing are outstripping, in number of cases, the ability to have access to from a reimbursement or payment perspective. So that's a little bit of the theme of what I'll talk about today. I do have my own advisory practice. It's called Access Solutions Consulting. A number of my clients are in the device, pharma, diagnostic industry, and many have personalized medicine offerings, none of which are specifically being discussed this evening, but did want to let you know that. My views this evening shared with you are my own from my expertise, not positioning from any of my clients. 5 challenges that are in practice today in terms of implementing personalized medicine. 1, education and awareness, patient empowerment, value recognition, infrastructure and information management, and ensuring access to care. And at any given time, for any particular diagnostic, whether it's germline or hereditary, or whether it's somatic and tumor, these come into play at some point or another. And we probably should ensure Kristen for being here, because as a genetic counselor, not only is she very valuable to this field, but there are very few of them in the context of all of the innovation and all of the demand. There are about 3,000 board-certified genetic counselors in the United States, and there are at least 5 to 10 new genetic tests coming into the market each week. So as you can imagine, the supply is outstripping, the supply of genetic counselors is being outstripped by the demand for these services. So congratulations to Kristen and her colleagues for starting a school and a program to help train more counselors. So there are ever-growing number of free online educational resources for patients and consumers. These are just a few that I've taken a snippet of. A very well-produced, accessible periodical. I wouldn't call it a journal, but it's a periodical for consumers and the like, is called Genome. Really breaks down a lot of the more thorny, challenging areas of this topic into very understandable and discernible context. So definitely check that out. And then there are NIH-sponsored websites like GeneEd, and then even just USA Today gets into it. What does personalized medicine really mean? And you could Google forever and come up with page after page of different types of context around this. And a little bit of the nuance here, similar to what Kristen was mentioning with Brca1 and 2, is not the whole story. Same with all of the educational. So if you don't really know what you're looking for or how to interpret and parse what's being shared, you could go off into different tangents. So there isn't any one Encyclopedia Britannica for this type of work right now. There are a lot of different sources, but there is some harmonization that's coming into play, and there are some standardizations that are starting to formulate with terms and context. I call this a screen-captured market supports patient engagement. 62% of smartphone users in the U.S. use their phone to get information about health data today. You can see, though, the percentage of phone ownership by age. So 27% of the 65-year-plus group owns a smartphone. And if they own one, I'd say maybe if knowing my father-in-law and mother-in-law, maybe that fraction of actually knowing how to use it is even smaller. But many of that same group, though, are afflicted with cancers or have comorbidities, polymedicated, have a lot of different situations happening in their health care, and would benefit from having more context around what's happening in their clinical care management, whereas 85% of the 18 to 29 bracket are using, own a phone and know how to use it and are using it quite often and quite frequently, which is in many ways tied to the interest level in these direct-to-consumer and what I also call SIPO, consumer-initiated, physician-ordered. So I'll tell you more about that. And again, 87% of the U.S. has the internet, using the internet, and the age breakdown of advanced degree versus high school, not too much of a spread, but there is a spread there. So they have an application, the phone, they know how to use the internet, they're using it to serve health data, and they have at least a basic level of education and understanding. I will say, however, putting on my marketing hat, most of this type of information is written at a grade 10 or grade 12 level. However, the average health literacy of the population is at grade 8, and for this type of complex, nuanced genetic information, it's grade 6. So if you have most of the information being contextualized at a grade 10 to 12, and most of the population being able to interpret it, needing it at a grade 6, you can see that there is a gap, both in terms of the ability to understand and the ability to process and the ability to then do something with that information. Once again, a plug for my friend Kristen here and her colleagues to help us all interpret it. Demand for innovative services in healthcare is exploding. In 2017, 32% of consumers had at least one health app on their smartphones or tablets. And I would challenge each of you, if I said, hey, who has an app that is a healthcare-related app on their phone? Everyone in this room, if they have an Apple iPhone, would need to raise their hand, because HealthKit is one of the apps that is loaded onto your iPhone, cannot be removed, and is getting further expanded through some of the, these recent FDA-approved utilization with the Apple Watch for EKG. So if you open your phone right now, go to HealthKit, you'll be able to see how many steps you walk today, catch and see other kinds of measures. So that is a health app. Types of genetic testing. So for general categories, the ones that we've been talking about mostly to this point have been clinical genetic tests. So these are tests where you have been diagnosed with a disease, there is a targeted treatment that is in the marketplace, there's a test to determine whether or not that particular treatment is going to be appropriate for the type of disease and biomarker or gene that you're carrying, and determine whether there's a matchup there. And just to give you some context about that, currently the pharmaceutical company pipelines are carrying 2/3 of those pipelines out to 2023 are targeted therapies. So what that means is by 2023, 2/3 of the pharmaceutical products that will be coming into market at launch will require some level of genetic interrogation to determine whether or not they are appropriately to be prescribed for you. Another type is forensic genetic tests. So this is the NCIS, SVU, that kind of thing, often at a crime scene or an accident. Educational informational genetic tests. These are ordered directly by an individual. So this would be the traditional DTC. We throw 23andMe in here, potentially Ancestry. And then genetic health risk information. The results of those tests could also be utilized to determine whether you have the risk of certain health conditions. So I believe it was Florence's case where She was this Florence, or was it the third case that was negative for Alzheimer's, negative for breast? Suzanne, right. So Suzanne ordered one of these genetic health risk information tests and got some information. Retail and online access to genetic testing is burgeoning. This photo right here, I took at my local CVS. This was on an end cap, for those in the retail world, right by the pharmacist. And what it's saying is they have 1,000 plus. FSA stands for Flexible Savings Account. So some of you may be pulling money off out of your check or putting it into an FSA that allows you to use those dollars to purchase whatever you want in the healthcare realm. And you have a card typically that accesses that. So great news, if you have an FSA, or even if you don't and you want to spend your money, the product that was on top of this little card was 23andMe Kit. So just hop on down to CVS and you can get a kit. But you don't necessarily have to go to CVS. You can go onto Amazon. Amazon has a carrier screening, how would you say, a carrier screening test for pre-pregnancy to determine whether you might be at risk for carrying genes such as cystic fibrosis or spinal muscular atrophy or some others like that. So that's VeriU right there. Or this test here from Color is for inherited cancer risks. So things like Lynch syndrome or Brca and the like. So when you're buying, I don't know, sponges or the latest Kindle app story off of Amazon, you can also hook up with one of these genetic tests. The CDC has been blogging about this quite extensively, and one of their blogs that I found most interesting was entitled, "Think Before You Spit." And it says, with improved technology and plummeting prices in the coming decade, we could see an expansion of DTC testing for personal genomic information. And I clipped off a few of the comments that were there at the time. One person said, informative. In this era of too much information sharing, it is good to be clear about exactly what you are asking for, expecting in return, and who will have access. I am just considering testing for genealogic information, but this brought several issues to my attention that had not occurred to me. Always better to be well informed on all sides of an issue. Another person said, I received health risk assessment information from a DTC several years ago and have found it quite useful. Knowing that I was at higher risk for 2DM, I have been more careful of weight and diet. Knowing that I was at higher risk for macular degeneration, I've not skipped eye examinations and won't. So 2 positives and 1 sort of skeptic. I'm not sure how much I trust personal genomic DTC companies' rigor in regards to testing. However, if someone does get this done, they need to see a genetic specialist to discuss, maybe this, Kristen, did you write this comment? I don't know. Discuss their tests and the results. The average PCP does not have enough genetic education to be able to interpret the test results. So back when I started in the field in 2002, working for Genzyme Genetics, one of my selling points in my messaging and talking with physicians and ordering specialists was at that time, and I don't think it's increased all that much since, but at that time, out of the entire medical education trajectory for a physician, a medical student, 1 hour was dedicated to genetics. So when you think about that, and let's be generous. Let's say it's 10 hours now in the context of the entire medical training. And the consumer slash patient is being bombarded with access and ability to these and downloading information and Googling different things, and then they're showing up in the physician office and they're saying, I'd really like this pan-cancer test and here is why, or I think I need to have this BRCA test and I want it now and here are the reasons why, and they're leafing through, and or I have a pharmacogenetic test that I'd like to take because I'm curious to know whether I am, if I'm overstimulating around codeine, and so as a result, it's flushing through my system slower, and I have a slow metabolizer, and as a result, I'm getting sick from it, and the physician just does not have any clue. And we are in a part of the United States that is a lot of medical services here, a lot of educated consumers and patients, and even here, it's not as easy to have a conversation. I can assure you, in other parts of the country, particularly in the middle part of the United States and in community practice, some folks have not even, shockingly, have even heard of BRCA. So just a point to bring out there. So we've got a lot of demand. We have a lot of bombardment of good and incredible innovation in the space, but it's not keeping up with how to pay for it. So coined this term direct to wallet, maybe as a little bit of a bookend to direct to consumer. The emphasis is on getting a test or device into the market on the part of the manufacturer without waiting on payment from traditional reimbursement channels such as Medicare, Medicaid, United Healthcare, Aetna, and the like, Blue Cross Blue Shield. So if you have an innovation and you've demonstrated and validated it in the laboratory and you believe that it's going to have a clinical impact in care, you want to get it out there and you want to get it out into the world. And if you want it to have uptake, it's going to have to be through patient payment. So here the ordering physician can either be the patient's own treating physician, or they can place the order as a patient through a third-party network of physicians. And this is just illustrating the dynamic, especially around oncology testing. And there's this term called financial toxicity that's now being added to the mix. About 70% of oncology patients declare bankruptcy at some point during their disease trajectory. This is, as a consequence, is coinsurance, co-payments, and deductibles all increasing. I know of one national payer that has assigned a 50% co-payment for one of those pan-cancer panel tests. So if it's $7,000, then you're on the hook for half that, right, $3,500. So a third-party physician and genetic counseling network is really what's been developing over the several years now to support these direct-to-wallet offerings. So companies like PWN Health and Genome Medical, they employ board-certified physicians and board-certified genetic counselors that are not your specific physician that you go to see as a PCP or as a specialist, but they do have access to your result and they do provide you with context and interpretation. And that is paid for as a separate charge, either from the patient or as part of the test offering company, and it's built into the overall pricing. Washington, D.C. is very, very interested in this model. They have been, Senator Schumer from New York has specifically been looking at this very closely, and there are several working committees that are looking into this because in their view, this is a loophole as it relates to DTC. So physician, when a physician is being noted, the expectation in the eyes of the senators is that it is your own physician, not a rent-a-physician, if you will, in their terms, or someone, a relationship you can buy through the purchase of the test. So some key points to consider. Personalized medicine is now consumer-initiated and physician-ordered. Technological and scientific advances in personalized medicine have outpaced its adoption in practice. Patients and consumers can now take their own actions given the genomic marketplace. And as you've seen from the headlines or have read about, when someone orders a 23andMe test, as an example, gets the raw data file, shares that raw data file into a data repository for interpretation, that data file in that repository is being opened or at least accessed in other means by law enforcement to make connections with relatives or others in their law enforcement database that share the same or similar genetic profile. So there's that aspect of it. There's also this notion of democratizing access. So if it's the patient's DNA and the patient wants to have that test or the consumer wants to have that test, that data belongs to them, and how they want to use it and where they want to share it and whether or not they want to share it is up to them. That's another perspective and point of view. And then taking that a step further, there are some that say, well, if pharma is buying these de-identified data sets and using this data to commercialize and develop these pipeline drugs, of which 2/3 are going to be targeted therapy, shouldn't some of that revenue flow back to those that contributed to that data set? So very interesting policy decisions and discussions, and really fun time for people like me that are working on a lot of these issues, but big questions about where is it all going. There's massive database of 1 million people being developed. Whose data is it? Who owns it? What happens to it? Where does it go? And how do you stop its use or put limitations on its use? Right now there are 3 main policy laws in effect, the common rule, something called GINA, and another one that allow for broad-based use of de-identified data for clinical research and research in general. No questions asked, no holds barred. So those may be looked at, they may not be looked at, but as the context continues to change, it's something that we'll need to think about. So as I say, let's keep the conversation going. I hope we'll have some questions and panel discussion. Thank you so much.
Thank you, Laura, and thank you, Kristen. So it certainly brings us full spectrum of understanding what pharmaceutical companies are doing, what they're creating. We can worry about insurance companies in some ways, and we can worry about sort of other organizations that are being put forth together made up of patients. And so there's even a company called Patients Like Me, and it's a network of patients. And they get together and hopefully they submit their DNA samples, and it might be for a specific disease. And patients like me, everyone that might have ALS or people that might have Parkinson's, that they're finding a common community, and how can they find similar treatments. So what we're going to do now is have people ask questions, and we have microphones set up at the front of the room, one on each side, and I'd ask you to come down and ask a question. And do you have additional mics as well? No, so you can just come down and ask a question just at the front, and we'll answer the questions for you. Someone must have a question. Okay, we're getting some handheld mics, but you can come down and why don't you start? That's fine. Go ahead. You can just walk up to the microphone.
Hello. Can you hear me?
Microphone might be better if you stand a little bit closer, or you can take it out, whatever you like.
Okay. Hi, I'm Jill. I wanted to ask you, Laura, about when you were talking about the CDC website. I know that you had all of like the reviews from like other people on it, but I didn't really understand what like the article itself was talking about. But like, what was like their view on what was happening?
Sure. Can you hear me? Okay, great. It's so wonderful to have all this great technology. Great question. Thank you, Jill. So CDC was basically saying exactly what Kristen and others have been saying. Buyer beware. Think before you spit. It might seem very enticing and desirable to know whether you're a Neanderthal. That's actually a product from National Geographic on a genomic marketplace site called Helix. It's called Are You a Neanderthal? There's another product that will take your DNA pattern and create a scarf out of it. So your various CTGAs into a beautiful scarf. So there's another called Vinome, Vinome, that will take your genetic profile and determine what type of wine you like. Cabernet, Chardonnay, maybe a buttery Chardonnay. These are all, again, my words, fun facts. They're not clinical, but they are, interesting to some folks. So CDC says, not trying to stop you from having this fun and excitement with your DNA, but just beware what's happening when you do send in your sample. Like in this company, Helix, it's a whole exome sequence of your 20,000 genes. It's stored, and then you can go back and say, today I wanted to do the Neanderthal test, but next month I'm kind of interested. Holiday season's coming, what wines might I want to buy for myself and others? So you don't have to do another spit. You don't have to do another test. It's already on file. They'll just draw from that and apply it to the Vinome test for money. It's like $89.99 or something like that. So CDC is just saying, caveat emptor. Think about let me just explain what's happening, and when you do that, and it's perfectly fine if you choose to do that, but eyes wide open as to questions you might want to ask or considerations you might want to have. Does that answer your question? Thank you.
I had a question for Kristen. If you have children who are adopted, and whether they're young or they get older and they develop a serious medical condition or disease, and the choices for their treatment is based on genetic profile, are there any court-appointed laws that you can open up closed birth records so you could get genetic information to help them make a decision on their choice of care?
That is a great question, and I don't know the answer to it. I don't know the laws about opening records. I can look, if you leave me your name, I can look into it, and I will get, I don't know the answer to that. It's a very excellent question, though. It's a serious thing. Absolutely.
The parents could still be de-identified, but they'll release the genetic information.
Right.
They can base that
Right,
on something
yeah.
that
That's,
and for their children.
sure, yeah, the next generation, sure, yeah. If you give me your contact information, I'm actually very interested to look into that for you.
Hi, I had a question for Kristen Shannon. My name is Leslie. I was wondering, what is the predictability if you have genetic testing at one major hospital and another family member has genetic testing in another place? It may not be a major hospital, it's maybe a smaller community hospital. And are the results reliable? Can they be looked at and say, okay, they are compatible, or can you say there's areas missing? How do you recognize whether it needs to be further looked at? Is there something wrong, missing, questions being raised? What do you do? Where do you go?
That's a great question. And I think there's a couple of parts to that. So I think most of the kind of clinical grade, those are my words, the clinical grade genetic testing, the germline genetic testing, there's only a handful of labs in the US that actually do that. So most people have family throughout the country, but most of them are getting tested in the same or similar labs. So there is a direct comparison that can be made if the same lab was used. I think the hard thing is that not all, as Laura said, there's a menu, a wide variety of panel tests that we can offer. So if you came to see me at Mass General and you wanted to learn more about your cancer risk, I could order a test that included 9 genes or 50 genes or 100 genes. All at the same lab, but it's all at my discretion and your discretion as to how much information did you want. So I think the most important message is that it's really important for everyone in a family to share their test reports, not just by word of mouth, but actually look at the test report itself. Have the name of the lab on the test report, the list of genes that were examined, and compare that way, because although most of the labs in the US are all doing the testing, it really, really varies about the number of genes and what lab was used. So getting the test reports so that and bringing them to your genetic counselor, your medical health provider, and saying, this is my test, this is my mom's test, this is my aunt's test, what does this mean for me? Getting the actual definitive test report is so, so important. Yes. Yes. So at least in most, when you get genetic counseling at one of the academic medical centers, or actually at most hospitals, they actually give you a copy of the test report. They should. If they don't, you definitely ask for one. It is in your medical record somewhere.
May I just piggyback
Yes.
on that? There is a law that was passed that within 30 days of a test, you have the right as a patient to request that report from the clinical laboratory, and you will receive it if you ask for it.
Right. So if you don't go to the hospital that you got your test, you can call the lab right up, and the lab has to give you the copy of the test. I'm sorry? If it's over 30 days.
They have within 30 days to give it to you. You can ask and receive it anytime.
Anytime,
Yep.
yep. Did that answer your question? Yeah. Okay. Okay.
I have a comment. Right.
Where's that coming? Oh, there you are.
Yeah. Okay. I was recently diagnosed with breast cancer. Everything's wonderful because it was real easy. I'm not going to die from it.
Good for you.
But I had genetic testing because I'm Jewish. Now, my comment is, people may think from Germany, from Ireland, that they have no Jewish blood, but that's really not, it may not be true because of the Inquisition, because of Germany, because of a lot of other intermarriage over the centuries, and people didn't talk about it. If they didn't want to know they had Jewish blood, it was hidden. In the old country, nobody talked about things. So I really feel that if a woman is diagnosed with breast cancer, that she should be tested for BRCA. Is that your standard procedure, or do you have to just look at?
So that's a little bit of a complicated question. I think that is really dependent on where you seek care.
Okay.
So most of the medical professionals and most of the industry standards say that if a woman is diagnosed with breast cancer and she's Jewish, yes. She should get tested. If she's not Jewish, typically there's all these other caveats. She needs to be diagnosed under the age of 50. And she has to have a mother and a sister diagnosed. So if you're Jewish and you're diagnosed with breast cancer, you automatically get offered the test. But if you're not Jewish, you have to have a family history or an early age of diagnosis.
Wow, because there's so many unknowns.
Absolutely, absolutely, and I think, it depends. That's what the industry standard is right now, and that's what most of the medical professionals are saying. I think in practice, you as a patient can request the test,
So
right?
I could advocate to people.
Absolutely. Whether or not your insurance company is going to
Yeah.
cover it is a totally different issue, but you as a patient, you can absolutely ask for genetic testing. And if your insurance doesn't cover it, there are labs that you can pay out of pocket. Color is a great one. Color is a great medical grade test. And you can pay for it, it's $300 or something like that.
I was told $500 if my insurance didn't, but my insurance did pay for it.
Yeah.
Yeah.
So
But that point is exactly such a good one to discuss a little bit further, because it really brings about the democratization component. For all the points that you mentioned, up to a landmark Supreme Court ruling on this very issue, it was impossible, if not nearly impossible, for anyone outside of that very strict clinical criteria to get a BRCA test from anyone other than one particular company. So when the Supreme Court ruled that was not appropriate, and it opened up the market not only to more clinical grade tests of that type, but also to more out-of-pocket tests, some of which could be as low as $199. I'm thinking of one here in Massachusetts. So that whole argument that it isn't a one-size-fits-all, there is a heterogeneity associated with the ancestry and the risk, and having access to that test doesn't mean you fit in this one box. So that is one example, I would say, that the combination of forces, political, advocacy, financial, and market, conspire together to really open up access in that way. We haven't seen another test yet, I think, like BRCA, that has had that confluence that's really opened things up, but it is coming. It is coming. I do not think that the floodgates are going to be kept closed any longer. People want answers, they want to know where to get them, and they want to go to trusted resources to find them, and there will be a market to support that.
And education is so important.
So important.
Hi, I was wondering if you knew anything about genetic testing in cardiovascular disease, or if any is what's being done.
I don't have an expertise. We do have great cardiovascular genetic counselors and geneticists at Mass General that I could link you up with if you're interested, but I am not one of them.
There was an early days offering with clopidogrel and 2C19, and whether or not you were a metabolizer or not as it related to that. So great fanfare, first FDA approved, a lot of good papers, and then not a lot of uptake in the market, and demonstration that maybe it wasn't a clear-cut case. There was wild type, there were other kinds of situations. But then there have been more offerings, like I'm thinking of AlloMap in particular from CareDx. That is one for heart transplant in particular. And their CardioDx is another one that has a cardiovascular panel. But it has not been to date the market driver as hereditary and somatic cancer.
I had a question. I wanted to know if there are some ethical complications of personalized medicine just in general.
Ethical?
So there's always ethics involved. I think, there's a lot of ethics about who controls the information. Is it the individual? Is it the company? Is it the researchers that want it? So that ethics is huge in terms of personalized medicine. I think from a clinical perspective, ethics really involves, I think I was telling Joni, that we have a lot of patients in our clinics that carry these inherited gene mutations. And one of the things that we talk about is the fact that they have a 50-50 chance of passing it on. But there are reproductive techniques that we can explore with them. So a woman can have something called pre-implantation genetic diagnosis, where an embryo is created in a petri dish, the embryo is tested before implanted into the woman's uterus, and only those embryos that do not carry the gene mutation are implanted. So that couple has a child that they know does not carry that gene. So that, and PGD is laden with ethics, and that's just one example. Designer babies, how far do you push this envelope? Is it just a single gene that predisposes to cancer or cardiovascular disease, or Tay-Sachs or CF? Or is it, I want my kid to be blue-eyed, blonde hair, really smart? So all of those things really kind of pushing envelope from a clinical perspective, but I think the business perspective also, who owns the information and who's making money off of the information and who's really benefiting from the information. Is it the patients that actually gave their DNA or not? I think that's laden with ethics as well.
I also think the variants of unknown significance, and so when you do some of these broad-based genetic panels, like a whole exome or a whole genome, you're bringing along everything, and some of those variants have yet to be determined through science and through research that they do have a significant impact in a particular disease area or state. And there are standards that have been put forth by the various governing bodies, like the Society for Human Genetics and others, about when and under what circumstances to unmask a variant of unknown significance, because it could be sharing information that isn't understood fully today, but could be a burden to the patient, were they to have that information and not understand how to interpret it or in what way it was going to be impactful now or in the future. That tends to be a pretty hotly discussed area among the lab directors when they're designing a test. What do we do with VUS? How should we, what should the cutoff be? Should we allow for that or not?
Going off of what the woman over here was talking about before, I was previously unaware of the link between BRCA and Jewish ancestry, but seeing as I do have Jewish ancestry and my grandmother was recently diagnosed with breast cancer, where would I go to get tested for the BRCA gene?
My bias, because I'm a genetic counselor, is to seek a medical professional and not just go through a direct-to-consumer company. I think there's a lot of reasons that you should be plugged into a medical system when you're ordering one of those tests. That's really very specific and gives such powerful information that can be life transforming. Most larger hospitals in this area have genetic counselors that are associated with them, or you can go on to, you can search the web for genetic counselors. We're all over the place. There's also genetic counselors available by phone. There's a lot of kind of direct-to-consumer genetic testing companies. One is called Informed DNA. You can look them up on the website and say, I want this test, and they'll do the genetic counseling and help you with ordering the test. So there's a lot of ways you can get. My bias, again, would be to go online and search up National Society of Genetic Counselors or find a genetic counselor, and they would put you in touch with one. I think that's a really excellent point. I actually did a lecture this morning at 8 o'clock about an advocacy group called 1 in 40, which was recently started. So they made it their mission. I think many people of Ashkenazi Jewish descent do not know that there is such a high prevalence of BRCA1 and 2 mutations in that population. So the statistic is that 1 in every 40 Ashkenazi Jews will have a mutation in either BRCA1 or 2. Most people have no idea. But this group called 1 in 40 is really making a push. Just not that everyone needs to get testing, but that everybody should know about it and make an informed choice as to whether or not they want the information. So you can look them up too.
You know, a number of temples run screening programs, typically for carrier screening. I don't know if they're doing it for BRCA.
No, I think they have been steering away from it for the most part. I think they're going to start to. I think that's another area that they're going to get into. But I think that because the information needs to be acted on, so most of the other carrier screening that happens in the Jewish population is all about having a future baby and whether or not the baby could have a problem. But this is so focused on the individual right now and whether or not they need to get screening mammograms, whether or not they had to have their ovaries out. They need to make sure that it's done within the medical context.
I would go not through something through the web. I'd sit down with a genetic counselor because it really makes a difference. And there's things you don't think about, and you really need a professional to bounce off. And they ask you questions, and you ask them questions. And I just think it's a much better way of doing it.
Thank you.
Absolutely.
I planted her.
That's great. We have Mike down here.
So when you were talking about Rob, I didn't quite understand. You said he had stage 4 non-small cell lung cancer, and he did well, or I wasn't quite sure.
So he was not predicted to do well given stage 4 disease.
Right.
But when the physicians found that he had an EGFR positive tumor, they treated him with one of the EGFR tyrosine inhibitors, and he did very, very well. The tumor shrank. He lived many, many more months than we expected he would have.
Right, but he, in the end...
Unfortunately, no, he did
right,
not.
because it was stage 4.
Mm-hmm.
So what was the drug? Do you know the drug he was treated with? You said a class of drugs, and I didn't know what...
There's like 4 or 5 of them that are on the market. Do you know the trade names?
Iressa.
Iressa
Is one. Pardon me?
Keytruda.
Keytruda.
Yeah.
Opdivo.
Okay.
Tencentric.
Yeah.
Right, okay. Another question is, in terms of you were talking about direct-to-consumer genetic testing goes into a larger database, which is not necessarily controlled, you don't know who has access to it. Is that true also for clinical genetic testing?
Yes.
If you're tested because you do have cancer or because they're looking for other genes and you're going through a hospital or a genetic counselor, is there more control on the data that goes to those labs? Is that also being shared with law enforcement, et cetera?
So and we may have a different opinion. We'll find out, won't we? But the first is these databases are not shared with law enforcement per se, but where they are shared for financial remuneration is with pharma companies, as an example, that are starting a investigation or a preclinical trial or a translational medicine study to determine whether a particular biomarker or set of biomarkers may be impactful in a particular disease with this particular compound that they're developing. So 2 things that are always a challenge with pharma. 1, getting clinical samples, tissue type in particular, and 2, getting enough of them to amass either a clinical trial or, in the case of a preclinical, early indication that this could be a line to follow and to then move on to phase 1. So by contracting with these organizations, like for example, one of the very large companies in this space, Massachusetts-based actually, Foundation Medicine, they have over 100,000 pan-cancer test results de-identified in their database. They're selling that over and over and over again to various different pharmaceutical companies for different programs. You know, Novartis just announced a partnership, I think, this morning with them to develop some cancer drugs. So it's not illegal. It's not in violation of anything. When these informed consents are signed, they do have protections as it relates to broad research use. But you don't know that, per se, that this tissue sample that was tested is now going to Clovis Oncology for their PARP inhibitor program, for Novartis for their TKI program, for Genentech for some other program. So it's just kind of this burgeoning awareness, I guess, that's happening in the industry. But again, not illegal and not undisclosed in terms of we may use your data for research. It's just what type, with whom, and the like.
I think the big difference that I see, and I might be living in my own little fantasy world, is that most of the clinical tests that are ordered, that I order, and that many of the physicians that I order, it's true that information, the DNA, the sequencing is all shared, but it's de-identified. So your DNA might go to the pharmaceutical lab, but they have no idea that
Exactly.
it's Joe Schmo that lives at 4 Adams Street.
That's right.
That's totally different than what happens in the direct-to-consumer space, right? So, you know, I spit into a tube, I send it to 23andMe. They might track my second cousin down as being the serial killer, right? Because of all of these
Well,
links.
that's how they found the killer in California.
Right.
Exactly. So
That's
so they share information and identifiers. In the clinical space, it's de-identified before it can exit the testing lab.
Correct. And no fantasy world, that's actually, you are living in the real world. Exactly.
But as a second point, you know, most of the clinical labs that we use, at least, there is a checkbox on all the test request forms that says, does your patient agree to have their DNA shared or not? And so when you're getting tested, at least with us, we actually ask everybody, is that okay with you? And if we don't check it, then the lab is supposed to discard all the sample at the end of the test. As soon as they've done the test that you ordered, they're supposed to throw it away.
One additional question. In terms of having a tumor tested for its genetic markers and then doing a more broad scan, more genetic testing for other genes, I guess, are those generally paid for by insurance?
That's a good question, but
So from the somatic side, recently Foundation Medicine, the company I was mentioning earlier, got a huge win to have their tests covered nationally by Medicare. And then it's up to each of the commercial insurers, Aetna, United Healthcare, Cigna, to determine whether they will pay for that. But with one proviso, Aetna, Cigna, United, Humana, they have an insurance offering called Medicare Advantage. What that is for Medicare recipients, it's a wrapper to give you more coverage. By statute, they have to follow the rules of Medicare. So because Medicare covered Foundation Medicine tests nationally, all Medicare Advantage programs need to as well. But if you happen to be 64 and covered through regular insurance and Aetna, they are not covering it.
They're not covering it. Are any of them covering it?
Case-by-case basis. Case-by-case basis.
it also depends on which,
This indication.
yeah, what the indication is and where the test is actually being done. So Blue Cross Blue Shield, for example, will pay for the tumor testing if it's done within the walls at MGH, but they won't pay for it at other places.
Right.
So it's all contracts and it's
And when you
it's
say
a mess.
when you say within the walls, like under DRG.
Under DRG,
Right.
yeah.
So in an inpatient setting. So real inside baseball. This past January, given the Red Sox, right? This past January, there was a pretty fundamental change at the policy payment level and nationally, which was that prior to this change, if a test was ordered within Mass General, if foundation medicine was ordered within Mass General Hospital, it could only be performed and billed 14 days after discharge. Otherwise, it had to be paid for through the hospital, and then the hospital and foundation medicine needed to square up. That is now eliminated, so it can be day one billing out of foundation medicine. So that opens up the market in a lot of ways in terms of access, but only in certain instances, because as we were just talking about, Blue Cross Blue Shield will pay when it's inpatient through the DRG, but they won't when it's outpatient. So
It's a mess.
It's a mess. Every case is every case. It's really, really challenging, and I don't see any clarity coming anytime soon. So
One of the biggest frustrations, I think, is that individuals that want to get this test, whether it be a tumor test or a germline test, even when you call up your own insurance company and say, is it covered, you can't get an answer, right? And I think, that's one of the things that we, as genetic counselors, we struggle with. We have we're inside baseball, so we know exactly who to call and what insurance company to make sure that it's covered. But I feel so bad that it's such a mess and it's so convoluted. And if you ask a direct question, depending on who picks up the phone at your insurance company, you may or may not get the right answer. It's a mess. Sorry. It's a little bit defeatist, sorry.
Thinking of some of the good things that I've seen. With my parents' generation, everyone was just diagnosed and generally had no chance at all to survive many of the cancers that they had. In my generation, we can get mammograms, we can get colonoscopies, and we have a fighting chance. I have 3 children, and I'm sure there's other people in the same room with the same thoughts in mind. And we have family members on both sides who have had cancer. What ideas or recommendations would you have for us as parents to say or do and encourage for our children to do to maybe, particularly with the genetic testing? Because that to me seems to be the roadmap for people to figure out what to do. Any particular suggestions on that?
Do you have some? No. I think my biggest suggestion would be that you and your children's father consider genetic testing first. And I say that for a couple of different reasons. First of all, I think you may get a genetic test and everything be fine, and then you don't have to worry. That you don't have to worry them that they have any kind of inherited predisposition. The other thing is that there is a fear of genetic discrimination with regard to life insurance. So when I have a younger woman who's 25 and is not married, hasn't even thought about getting life insurance because it's so far out of her life right now, I would hate to offer her genetic testing and have her find that she has a Brca mutation and then maybe she might not be able to get life insurance ever in her life. So I like to start genetic testing kind of at a much higher, a more established person who may have their finances and their life insurance in part. I think also just sharing the family history can be so helpful. I can't tell you how many times people come in and they have absolutely no idea about their family members. I think that they had cancer. Maybe they had a heart attack. I think talking about your family history is so, so important, and I think that actually knowing your family history and talking about your family history, at least today, I would argue that it trumps all this genetic testing. That is the more valuable thing for me, because I can have a family history of lung cancer, for example. As far as I know right now, there's no really good genetic test for inherited lung cancer. But if I know that I have a family history of it, I'm probably not going to smoke, right? So I think just talking about your family health history and all aspects of it, not just cancer, but everything, cardiovascular, everything, knowing your family history and sharing it, that would be my biggest tip for your future generations.
And I would add, it's excellent advice, thinking about what will you do with the information once you know it is seemingly a really good touchstone. So if I know by taking a test, I'm going to learn that I will be slowly killing myself with every chocolate bar I eat. I'd love to tell you I would stop eating the chocolate bar, but I can't. I'm addicted to chocolate. So I'm not sure that I would, that's trivializing it a bit for this example, but understanding what I would do with the information really would be leading me to determine whether I'm going to know it, why I would know it, whether I would go get it, and how I would apply it, I guess would be the trajectory. But I think you brought up such an interesting point, and in Kristen's answer related to the family history. I mean, I think we've seen a lot of that this week with Elizabeth Warren and the family lore of the Native Americanism and the like, and then the tests demonstrating, some fractional aspect and what have you. But sometimes family history passed on could be just potentially lore, yeah, because you just either they think of it and it wasn't necessarily proven or disproven, the techniques and tools weren't there to do so, or they might be embarrassed to share something. So I do think there's that yin and yang about the art and the science, I guess.
Laura, I have a question about the statistic that you gave that by 2023, something like 75% of all medicine will be personalized. Is that of 75% of new medicine or of all medical?
It's 2/3, so about 66%
2/3, okay.
Of new medicines. So these are medicines that are in pipeline and are being developed to be launched into the market in 2023 and beyond. Are all, 66% or more have targets that are genetic or marker related.
Thank you.
Right. So I think we'll end there, but that's ending on a good note in some sense. As we recognize in living here in Boston, close proximity to Cambridge, there are so many pharmaceutical companies that are popping up on a daily basis, biotech industries, even medical devices, based on genetic information. And I think we still don't know where we're going with all of this, but I think the future is out there. So please join me in thanking both Kristen and Laura. And I just want to remind you, if you could fill out your evaluation and turn it in on your way out, whether or not you're going to get CEUs or not. But we welcome that, and we hope you've enjoyed the evening, and we look forward to seeing you at future President Lecture Series.